And now too, Professor Gareth Roberts looks at the role of electronics for pleasure in the home of the future, continuing his Royal Institution Christmas lectures.
Sound is an ordinary, natural phenomenon. It can be explained very easily using the laws of physics. On the other hand, music is a result of man's conscious development of sound into an art and into a science. The origins of music are rather obscure. Charles Darwin believed that singing arose from man trying to imitate the sounds and cries of birds and animals. On the other hand, many people believe that music arose out of work rhythms. And there's no doubt when you look at some of the early musical instruments, there's a very close correlation with some working implements. And so the cooking pot and the drum, the seed drill and the rattle, and the hunter's bow and the violin string. There's not much dispute as to who the father of musical theory is. Everybody agrees that he was Pythagoras. And in the 5th century BC, with the aid of a stretched string, he calculated the length ratios of virtually every conceivable musical note. The Mesopotamians believed that music mirrored the harmony of the universe, and as such it held a very central part in their curriculum. So that music, together with mathematics and astronomy, were the core subjects. And that was the situation right up to the Renaissance. Obviously, it's very different now. And we have the 3 R's, but nonetheless, music is very, very important. And we have those that enjoy classical music, and of course, we have pop culture. Many years ago, the kings and queens and the nobles were able to afford musicians to entertain them. But the ordinary people had little music in their homes. But things changed late in the 18th century with the introduction of musical boxes. And I have some examples here of early musical boxes dating back about 100 years from the Science Museum. So mechanical engineering had made this possible. So these are, if you like, the executive toys of that period. Now you listen now when I switch on this beautiful skylark. Isn't that lovely? What's to be woken up to that every morning? In order to demonstrate this larger musical box, I wonder if I could have a young Welsh helper. I haven't had a Welsh helper so far. What's your name? Oh, hello, Sarah. Come down. You sound half Welsh with a name like Sarah Owen. If you just stand round there, and let's open the box and see what we have inside. Now, that really is a wonderful piece of mechanical engineering. Can you see the little metal spikes sticking up here? This is what provides the music. And on this tape, we have about 15 pieces of music. Now, what I'd like you to do is to help me switch it on. That involves moving this needle this way and then back again. Give it a tug, that's it, and put it back again. There we go. I'll close this just for safety. Do you recognize it? The Women of Harlech, is it? Unfortunately, once this thing is started, it has to play for at least half a minute. You can't shut the Welsh up, you see. As well as some of the cylinders in these mechanical boxes, occasionally you had discs like this, performing exactly the same purpose. So you see, Sarah, lovely box enables us to show passion and pride for our country, doesn't it, eh? Now, I have another box here, which is slightly more modern. And what I'd like you to do now is to open that box, if you would. Thank you very much. Or should I say, diolch yn fawr iawn. It was very popular in Victorian times to put some mechanical engineering into a piano and cheat a little. And what I want to show you now is some film footage of a pianola. Here's the person switching it on, and very shortly you'll see a paper roll with holes in it. And really the paper roll is performing a function very similar to paper tape in a computer program. Because as you see the holes appearing, this gives a message for one of the keys to be depressed and play a note. Let me just play that for a while. In my first lecture, I mentioned to you that Edison invented the light bulb. He also invented many other household appliances. For example, the coffee percolator, the electric toaster, and the hair curler. But his favorite invention, and he mentioned this later on in his life, was the phonograph. I'm quoting his words when I say that he said that the phonograph had brought pleasure to people, and he said, "Music, next to religion, has done more to elevate man than anything since the birth of Christ." Despite his deafness, he appreciated the importance of putting music in our homes. Mind you, early on, he thought of his phonograph as a dictating machine. It has been said that Edison was the world's best inventor and its worst businessman. About a year after the discovery of his phonograph in 1877, Edison's phonograph, or a model of it, appeared here in this Royal Institution. And it was almost identical to this one that I have here. What Edison had worked out was this. He said that if you had a vibrating diaphragm, that could pick up sound signals. And if you now put a stylus or a needle on this side, and then a soft material behind, then you could write an imprint on that soft material and record sound. The diaphragm is in this mouthpiece here, and you can see the stylus just there. The recording material that he used on this phonograph was tin foil. So the idea was that you shouted into this mouthpiece here, it vibrated the diaphragm, that vibrated the stylus, and that then made an indentation in the tin foil. But while you were doing that, you had to turn this disc around at a very uniform speed. This disc here, made of brass, has got grooves in 1/10 of an inch spacing. On this side of the phonograph was something equivalent to that, and that's what you used to hear the sound. The very earliest record of all made by Edison was "Mary Had a Little Lamb." That was his very first recording. He started a company manufacturing these phonographs, and gradually they improved things. So instead of this rotation, he introduced an electric motor. And then the tin foil was replaced by wax. And that meant that when the recording had deteriorated, you could shave some of it off and record again. But there were two disadvantages with the Edison phonograph. One was that the sound intensity was very, very low. In fact, you had to listen to the sound with stethoscopes, just like your doctor listens to. And secondly, you just couldn't mass reproduce these cylinders. And it meant that every recording star had to make a separate cylinder for every one of his customers. Now, can you imagine trying to get a platinum disc or a platinum cylinder based on that principle? You wouldn't get very far, would you? And for that reason, the phonograph really started losing ground, especially as the gramophone had been invented. The gramophone was invented by Emil Berliner in 1896. And I have a beautiful early example of a Berliner gramophone. Much the same principle in that you have to turn something, but in this case, it's a disc or a record rather than the Edison cylinder. Berliner had worked out that it was much easier, in order to get faithful reproduction of sound, to make the recording using the stylus moving in the planar direction than into the vertical direction. As you see, there's a nice little loudspeaker here. You might say, well, what's this thing here, this thing that looks like a bathyscaphe? Well, it was a very forward-looking invention, because if you had a piece of rubber and attached it to the loudspeaker, and then had another one going to your ear, you could listen to that music without disturbing anybody else in the room. You can see that the size of disc here is about 5 inches. And I have another disc here, suitable for the Berliner, which is 3 inches in diameter. So the origins of recorded music are very much in the United States and in Germany. But in 1898, the very first discs were made in this country by the British Gramophone Company. And I have here one of their very, very early trademark models. Alongside me here as well, I have probably one of the most famous trademarks in the world as well. This is Nipper the dog. What perhaps you don't realize is that in the original painting, Nipper was sitting on his dead master's coffin. So there he is, listening to his dead master's voice. In the original painting, there was a phonograph here, but the British Gramophone Company requested that it be changed to a gramophone. I've already mentioned to you the fact that you had a 5-inch disc, a 3-inch disc. This one here uses a 7-inch disc, so clearly standards at that time hadn't been established. Here's a beautiful example of the smallest record in the world, 2 inches in diameter. And the active region is around this circle here. To contrast with that, I have the world's largest record, 20 inches in diameter. This was made in 1903. Alongside a very popular size, 16 inches diameter. And that was used for the movies, because the time it took to play that record roughly equaled the time for one reel of movie film. Beyond that, you've got the 10-inch disc, which was very popular in the 20s. And beyond that, the winner, the standard LP that you can still buy today. The reason the gramophone was better than the phonograph was that you had two big advantages. One, that you could hear much more sound, and secondly, of course, you could reproduce the records. At the very end here, I have a really very, very interesting example of a gramophone. It dates from 1904, and it uses a very, very unusual material for the disc. You may have seen discs of hot chocolate, records of hot chocolate, but this was a genuine cold chocolate disc. The Germans produced these in 1903. If you got fed up with the recording, you ate it. Another feature of records of this time was the variability in the speed with which they were played. And so we have now the standard 33 1/3 revs per minute, but some of these early records were played anything from 25 revs per minute to 100 revs per minute. But eventually, as you can see, the gramophone came about, and this was the birth of what we call the industry of human happiness. Brings lots and lots of enjoyment to people. But despite that definition, I want to show you a couple of old examples of gramophones that have rather a tragic tale to tell. This gramophone here was the one that Captain Scott took with him on that ill-fated expedition to the Antarctic. And I have with me here a record by Caruso, which again he took to the Antarctic. And let me play it for you so you have some idea of the quality of gramophones around this period. This is what he listened to during those very, very dark nights in the Antarctic. Alongside, you see rather a battered gramophone. It's not surprising, because this has seen service in the First World War trenches. This is a portable gramophone built in 1912. And you can see very clearly on the lid the names of battlefields like Ypres, where that has seen service. Now, I'm too young to have a war record, so I can't play a record for you on there, but that actually did see valuable service. By the mid-20s, gramophones had obviously improved. And so instead of having the large horns, we now had concealed horns, and that's what you have within the box here. Alongside, I also have a portable. Well, they say portable. It's movable, maybe. It's rather heavy. There you are. There's a portable of that period. There's always been a demand for people to take their music with them wherever they want to go. Now, just as the gramophone had provided competition for the phonograph, all of a sudden there was competition for the gramophone. And that was in the form of the radio. Marconi had shown in 1901 that you could send signals across the Atlantic. And Fleming and others had also invented the diode and triode valves. I have a valve of that period here. It's rather difficult to show you, but you have a very slender cathode that goes inside. This outer section is the anode, and inside is a metal grid. But valves like this in the early 20s were very expensive and rather scarce. And so, although the BBC started its service in 1921, most people were huddled around little sets like these. This is a crystal set. And so thousands and thousands of people, when the BBC started transmitting, were listening to this kind of set. The crystal that we're referring to is a tiny crystal here of galena, or lead sulfide. That was a very simple semiconductor. And that did some rectification. And you had to organize that this cat's whisker, this piece of wire, accurately touched that semiconductor. And it really was a very delicate thing to do. In fact, you can imagine lots and lots of people around, In 1921, when my team, Tottenham Hotspur, won the cup, they beat Wolverhampton Wanderers 1-0. You can imagine the tension, and all of a sudden you lose contact. Shh, you know, and you're back here. Lots and lots of frustration. One of the frustrations was, of course, you couldn't hear very well. Again, they were still using earphones. I've shown here a very, very early valve radio. Here's the tuning area, and here are the big valves. Now, this is really an upmarket radio that I want to show you now. Look at this. That's the aerial. And you plug it in here, and just to check that you know where you can point to your favorite station, there's a compass actually on here to help you. And inside, you can see that the tuning knobs are now rather more sophisticated. But one of the nice features about this is inside here. We have 8 big valves. Here's one of them. So this was more, I think, like an electric fire as well as a radio. It must have been giving off a lot of energy. But you can see, I think, that just in a short period of time, because this dates from about 1925, the radio had gone from a piece of scientific equipment like this to a piece of furniture. Really quite a large change. Again, one heard the music through a large horn like this. And what I want to do now, just to show you what the quality of music was like at that time, and I'm going to play you a piece of recording of King George V, recording from his Empire Day message.
And I pray that by the blessing of God, it may conduce to the unity and prosperity of all my people, and to the peace
And well-being of the world. As you can hear, the recording quality was not that high. Alongside, I've shown a 1931 mains radio. So we'd gone from a portable system to a mains system. 10 years further on from there, and we have another big change. Electronics had started playing a very, very important impact in a very quick way. Here was the radio now, but the quality had improved immensely because of clever work being done on novel microphones. Work done at the Bell Telephone Laboratories in the United States had made wax cutting for records electrical rather than mechanical. And so the gramophone had also improved in quality. And as you see, the two things are combined. And what I want to do now is to play, with the help of an assistant, a nice piece of music. Will you come down and help me? What's your name? Come, let's have a... Would you like to read out the piece of music that we're going to play?
Don't be cruel to a vegetable.
Don't be cruel to a vegetable. Right. Now let's see. Come on.
There's a new society.
It's much better than the previous one. Okay, thank you very much indeed. What I have alongside me is the portable of that same period, the late 30s. It's rather light because what's missing are the batteries that had to go with it. These had to go into that portable. So this was really the executive portable that went with your Rolls Royce and your yacht. Until this time, the only way of recording music was on the cylinder or preferably onto the record. But people have been doing research on recording magnetically onto tape. And behind me here, I have some examples of some very, very early tape recorders. This is an early phonograph. The material that was used for the recording was steel wire. Here it is here. There's a spool of steel wire. That's where the musical information was contained. Later versions brought out steel tape. Can you imagine how dangerous it was to have machines with steel tape whirring around at great speed? This is a slightly later version where we now have the magnetic recording material is iron oxide coated onto plastic. And here, an example of a tape recorder that's more portable now. You see the spools are much smaller. On the other hand, it really still isn't very user-friendly. You can get these tapes in all sorts of difficulties, dropping them on the floor and having to wind them up again. And the real success came, of course, with the compact cassette, where now it was so much more user-friendly. The arrival of these recorders here really knocked the Edison Berliner type recorder quite a lot. Even now, if you look back at 1987 statistics, only 17% of the recording medium used last year was made up of LPs. And I suspect that that number will get smaller and smaller, and possibly in the next 10 or 15 years that we'll lose the record as a recording medium. What I'd like to do now is to try and indicate to you how clever electronic signal processing has helped improve the quality of music in the home. The consumer is always wanting better quality sound. The first item I want to discuss is the introduction of stereo. Most of you now are familiar with stereo, where you have the information on 2 channels, and it gives you much more of a 3-dimensional type effect. The early stereo records had 2 grooves alongside each other, one to record the left and one to record the right. A later version was recorded in this way. If this is a single groove now, you had the stylus which made the recording moving up and down and making an imprint down here, just like the Edison phonograph did. And then you had the other channel being recorded by a lateral movement, just like the Berliner one. But in 1931, an EMI engineer called Blumlein invented the stereo system that we are using today. And it relies on a different principle. It relies on putting information in one side of the groove and the other side of the groove. We call it the 45-45 method. So that the outer is recording the right, the inner is recording the left. These are occurring simultaneously, so the motions are actually orthogonal to each other. But you can see that the right is being recorded by writing onto this groove, and the left is being recorded by writing the information onto this part of the V. In terms of radio broadcasting, there's no doubt that the dramatic change has been the introduction of FM broadcasting compared with AM broadcasting. The FM band is up in this part of the spectrum. The AM band occurs at lower frequencies. And this means that there's more bandwidth available for the FM. So as well as giving you a better recording of sound, you can also put in the stereo effect. The third example I'd like to bring to your attention is something that you know the name of, but I'm sure you don't know how it works. All of you, I'm sure, push a button that says Dolby. And all you know is that it improves the quality of the sound. Now, it's rather a complex thing, but I'll try and explain it to you. What Dolby does is to remove the hiss on records. What Dolby decided to do was rather clever. He said, well, when you're making a tape, why don't you increase the amplitude of certain signals? And then, when you play it back on the tape recorder, you de-emphasize it by the same amount. And you might say, well, what's the point of doing that? Well, when you de-emphasize it, you're also cutting down the hiss by the same amount. Let me try and explain it to you better with a few slides. On the scale here, I've shown frequency. At this low end here, that might be the frequency, say, of a double bass. This might represent a French horn type frequency, and this the piccolo. Most of the hiss that occurs on records involves the high frequency end of the spectrum. And so what Dolby said was, if you take a normal intensity sound, why not increase it just slightly at that intensity? But a lower intensity sound, let's amplify those higher frequency signals, those above about 500 hertz. About 40 dB down, where the signal intensity is about 1/100th. Let's amplify those even more, because these are where you get more annoyance still from the sound. And so that is the pattern that is added to your signal when it's recorded. I can show you better on the next sketch. Here's your tape recorder. Before the recording reaches your tape recorder, you've already added in this complex arrangement that I've just discussed, where you superimpose certain signals onto your tape. Now, clearly, when you play the record, you need to subtract the same amount. On the next slide, I've shown that when you record, you add a signal. What's vitally important is when you play back, you subtract it by that amount so that you end up with the proper level of recording. But the important thing is that you've also reduced the hiss by this amount as well. I have behind me a very simple illustration of Dolby that I'd like somebody to help me with, please. You're going to come and help me? Great. What's your name? Andrew. Hello, Andrew. Thanks for coming to help. If you just stand there, what we're going to do is we're going to change the frequency here, and I want you to do that for me. On the oscilloscope here, I'm showing two traces. Now, this is the reference level, and this is the level of the signal on your tape. At the moment, we have a fairly low frequency there. But what I want you to do is to gradually increase that frequency by moving the knob that way, and we should see the amplitude level increasing. You see? See how the level's gone up? And if you move it back again, you'll see it going down. So that just shows that we've added that level, and that's how you receive it on your tape recorder. Thank you very much for helping. The final knockout punch for the technology produced by Berliner and Edison is with us now. And it's all a result of digital electronics technology. What I have on my right here is a compact disc player. And this records music in a very different way to the others that I've been speaking about. It records information digitally. And it makes use of a laser. This is a section from the inside this compact disc player. The disc sits in this position here. The laser light comes through this piece of glass there. This is the equivalent of the stylus on your gramophone. So this is what locates the position on the disk. Now, the information is not stored in the normal way at all. You store on the disk a whole succession of numbers, about 500 million of them in all. And what I want to do with the microscope here is to try and show you just how much information you actually pack on the disk. And you should see the tracks that are present on the disk. There they are. That's nice. Great. Now, to give you some idea of scale, the pitch level there, the spacing between those lines, is about 1 micron, 1 micrometer, a millionth of a meter. That's how complex the information is. A nice feature is that if you make a mistake during processing, you can put additional information in that will correct the sound automatically. On the left, I have a competitor for compact disc. And this is digital audio tape. It's very different to the tape recorder that you have in your homes. It's the next generation of tape recorder. And this is the size of tape that's going to be used. Again, like the compact disc, it stores the information digitally. And so you get the very, very high quality of sound that you get with compact disc. There's a great problem at the moment going on in the trade, because the advantage of this over that is that you can record at home using a DAT player. And people are suggesting that perhaps spoilers should be added to prevent that happening. So here we are now with this wonderful digital technology. Isn't it tragic that we have had those beautiful singers from the past, like Caruso? Wouldn't it be lovely to hear those people in digital sound? Well, of course, you can, to some degree, with the help of sonic processing. You can now clean up old records or scratches on records using computer science. And for this demonstration that's coming next, I've enlisted the aid of a friend, and I'm sure most of you will know him.
What I'm going to do now is I've got a copy of the current #1. Cliff, if you're listening, I'm sorry to have to do this to your record, but that's the way it is. I've got your record here, right? And I've got an emery board as well. And what I'm going to do in front of the camera and live on Radio 1 is I'm going to scratch the record very, very badly. And this is the record he'll take away with him, okay? Here we go, right? Ooh, it goes through you, doesn't it? There you are. I'm really badly scratching it with the emery board right the way around. I mean, that is terrible. There's just no way that would play now. I think I daren't do any more. I tell you what I will do. I'll put it on the turntable just to prove that I've done what I've said I've done. Here we are. I'm just going to start it now. That's I'm just stuck straight away.
Now, that was very, very kind of Bruno to break or damage that record for us, wasn't it? I think I'm going to call him Bruno Breaks in future instead of Bruno Brooks, because when you see this record that he's damaged, boy, he really has scratched it. But he did that a few days ago. And what we've been doing in the meantime is busily cleaning that record using our special technique. And what I have behind me here is a demonstration of just what we've done. And this has been done using some computer software generated by the University of Cambridge jointly with the National Sound Archives. On the top of the screen here, I'm showing just a small section of the record. In fact, only 0.085 seconds of it. But you can see very clearly that there's a blip here. This is just one of the small scratches that Bruno has made. And what we want to do is to get rid of that. And so let's focus in now just on that blip there. So you can see it now in larger scale. There's the blip. And that's the annoying blip that we need to get rid of. So let's now do some processing to try and clean it all up. And this is done using clever mathematics, things called interpolation techniques and sophisticated algorithms, which you won't understand fully. But here now is the cleaned up version. So there's the blip, and you see what has happened? we've smoothed it all out. And so now, after a lot of effort, you can clean a record like the one that Bruno has scratched. And so let's listen now to Cliff in all his glory.
Dreams of Santa, dreams of snow, fingers numb, faces aglow. It's Christmas time.
Cliff's my generation, I should tell you. Maybe he doesn't look it. Right, now let's have a change of scene. And let's talk about this object on my right. It's a very, very early television, or the best word for it is a televisor. 100 years ago, John Logie Baird was born, and he's regarded as the inventor of television. There are many other people involved in the invention of television, but Baird is the person that we all recognize. So although it looks like a bit of a gas stove, this actually produces television. The picture comes out of here. The aspect ratio is rather different to your television at home. It's 3:7. It's more or less the shape of a human being, because Baird envisaged them being filmed in full. The flicker was very, very bad. At home, you have 50 hertz television, but he had 12.5 frames per second, so there was an annoying flicker effect. But when he launched his television in 1925, people really spoke very optimistically about it. And an article in the Radio Times of that year, called Seeing the World from an Armchair, said, "We have encircled the earth with our music and speech. Will the next year enable us to see around the earth with our eyes? It is only a matter of effort and research." Well, Baird did improve his television. It started off with 30 lines. And to give you some idea of the definition involved in 30 lines, let's go across to this piece of film. And again, we have a famous personality to help us demonstrate. You see him walking towards the screen. Now, who is this gentleman here? See the 3:7 aspect? Who is that person? It's very difficult to tell, but let's reveal all. Well, I'm not sure who he is, but he's standing alongside exactly the same instrument as I have here. And for his benefit, I've worn green today. So that should give you a clue. So that was 30-line television. Baird did improve his television to 240 lines, but it was a mechanically scanned television. And Baird was rather optimistic, I think, assuming that it would really take off in a big way, especially as electronic scanned television was also about. EMI engineers in Hayes and Middlesex, using Marconi transmitters, invented an alternative type of television. And I have a beautiful example of an early television here, dating from 1936, which is when BBC television started. Inside here, we have a cathode ray tube. It had to be positioned vertically because of its size, and therefore you see the picture in reflection. The EMI Marconi system is what beat the Baird system, which was an electronic system as compared with a mechanical one. The very, very first outside broadcast was in 1937 of King George VI and Queen Elizabeth's coronation. And let me now show you a film of that.
Queen Mary in her state coach. Those 8 magnificent greys drawing on that almost unbelievable state coach with their majesties, the King and Queen.
The definition, as you can see, is really rather good, certainly compared to the 30 lines that you've just seen. The range of that broadcast was only about 35 miles, and so people in Wales certainly couldn't see it. But by the time the next coronation came about in 1953, about 80% of Britain could pick up television. And I have here an example of a television of that period. This is the 405 line television. The aspect ratio is 5:4. ITV came about in 1958, BBC Two in 1964, but the big, big change was the introduction of colour in 1967. I have alongside me here a very modern television set. The aspect ratio now has changed. It's now 4:3. And it contains many additional features. One, of course, is the infrared capability for switching it on. See those deer bouncing around in the Welsh forests? 89% of homes now have a colour television, and 35% have two televisions. There's been a dramatic change in the home. 20 years ago, if you looked at cinema attendances, 28 million people went to the cinema each week. 2 years ago, that had dropped down to 1 million, all on account of television. People are still demanding bigger, better televisions. What I want to do now is to tell you about the dramatic changes that are taking place in television. During the next decade, we will have high-definition television. And what I would like to do is to focus just on 4 aspects of high-definition television. The first that I want to discuss with you is the standards. And to help me do that, I have a shirt here, and I'd like a volunteer to help, please. Now, would you like to come and help? There we are. Now, why don't you put this shirt on? You might think this is a very strange thing to do in the middle of an afternoon. Now, you look very, very smart, don't you? Gosh, you look smart. Now, what I'd like you to do is to stand there and pretend you're a news broadcaster, okay? You're reading the news. Now, I want you to look on the television there. Can you see this horrible strobing effect? The complications that that striping has introduced? That's your fault. That's because you're wearing that shirt. Thanks very much for helping out. I'd like to explain to you now why it is that that strobing effect occurs. Every country has its own standards for television. In America, there's a standard called NTSC, which is short for never twice the same color. In Britain, we have a system called PAL, P-A-L. The Americans unkindly say that that stands for picture always lousy. There's a new system coming called MAC. And in fact, the system in this country is likely to be called DMAC. I think it's going to stand for definitely more authentic color. That's going to be the new standard in this country. And what's going to make all the difference? Well, I've indicated that on these slides. In the PAL system, the existing system, the black and white information is sent in a certain part of the frequency spectrum. But the color information is also transmitted in the same frequency spectrum. And the sound also in that same frequency band. So they're all together. You can get crosstalk effects and that sort of strobing effect that you've just demonstrated. MAC is going to be different. In the case of MAC, one part of the frequency band will be reserved for the black and white information, the contrast, the luminance as we call it, another band for the color, and finally the sound. So there won't be the opportunity for this crosstalk effect. Satellite and television came together in 1962 with the launch of Telstar. Most of you went around to remember that. I certainly was. That enabled people to see satellite television for the first time. But it's only in the last few years that people have had this kind of satellite dish. This one is about 1 meter diameter. A few years ago, they were about 1.8 meters diameter. Now, I certainly wouldn't like one of these in my back garden, but I wouldn't mind having one of these smaller ones here. And what I have here is a prototype aerial to pick up satellite television. And I want now to show you that it actually works. But could I have a volunteer, please? Will you come down and help me? You're nicely situated up there. What's your name?
Paul.
Hello, Paul. I'm going to make you a star. Do you know what I'm going to do? I'm going to send you up into space. I'm going to pretend that you're a rocket, and that's the satellite that you've got to launch. So you've got to pretend you're the Ariane rocket going up into space. Off you go. Quick, run. Now, what we would like to do is to beam a picture now from Japan, but copyright reasons prevent us from doing that. So the BBC engineers are putting a signal in to Paul up there. He's going to beam it down to us. Normally, of course, you'd have somebody on Earth sending a signal reflecting from him. But he's going to beam down this signal to us. This is the aerial here. And hopefully, you'll see some foreign film. Yes, lovely. Is Father Christmas arriving in Madrid? Very
A las
topical.
6:30 en punto de esta tarde, sus majestades reales han llegado a Madrid.
That's not Welsh.
3 helicópteros les han traído desde Oriente para repartir juguetes y regalos a todos
Just to
los
prove that
pequeños.
it's genuine, I'll
Las
stand in the
carrozas y
way
los
now.
camellos cargados de presentes les esperaban para comenzar el viaje por toda la ciudad. Las carrozas de Melchor,
It's gone,
Gaspar
yes,
y
good,
Baltasar
good.
representan cada una un gran trineo.
Thank you very,
creado
very
por
much
Venus.
indeed for helping.
Los chavales han escrito-
So I've shown you two developments in television. Coupled with that satellite situation is quite a difficult technical problem. Eventually, we'll want to receive lots and lots of information from satellites, and there just isn't enough bandwidth available. And engineers at the moment are working frantically on a subject called bandwidth compression to try and condense the amount of space required. What people really want about television is a realistic effect. And the third aspect of high-definition television I want to discuss with you relates to that aspect. And it's a subject that I love a lot. It's called the golden mean. Let me see now on the slides some nice paintings. This is a beautiful painting by Canaletto. The next one is one of my favorites. It's in my lounge. It's by Turner. And the third one is by the English Impressionist Sisley. Now, why have I shown you these paintings here? Well, they all illustrate a certain point. And it's a point that was well known way back 1 century BC by Vitruvius. And Leonardo da Vinci, Picasso, and so on also were aware of what is called the golden ratio. Now let's consider the golden ratio for a rectangle. What I'm going to do now is to divide that rectangle. So we have a square here, and that leaves a rectangle. And the way I've drawn it, this rectangle has exactly the same aspect ratio or shape as the large one. Now let's divide it further. I've now squared it off again here, produced another rectangle. And that rectangle has the same shape as this one, and that has the same shape as that one. Now clearly, not every rectangle is going to have that property. There'll be one unique aspect ratio that gives it to you. So let's work out what that is. If we call this distance x and this one y, then the golden ratio is obtained when that distance divided by that is equal to this distance y divided by the total. And so the equation that we need to solve is this one here. And what it gives you, approximately, is that the aspect ratio here should be 5:3. So that's the aspect ratio of the golden mean. Now let's see if that conforms to the paintings I've shown you. This point here is a very important one. Let's see where it lies on the Sisley painting. You can see it's exactly where that path vanishes off into the horizon. The principle applies equally well for a painting in the vertical. There's a beautiful painting, a very topical one. That's Velasquez's painting, Adoration of the Magi. Now, where's the focal point? Right round Christ's head. And so painters are well aware of this golden ratio, the 5:3 for a rectangle. But what about the television viewer? If you sit people in front of the television, what shape of television would they prefer? Well, that question was asked to lots and lots of people. And as you can see, they chose 5:3. 4:3 is where we are now. 7:3 was CinemaScope that you may see on your old movies. But just like the golden ratio, 5:3 television is what people have preferred. The present aspect ratio is 4:3. So where is television going? Clearly, we're going to 5:3 television. And that's what you're going to get. What I have here is a 5:3 aspect ratio television. Once you've started watching 5:3, you certainly won't want to go back to 4:3. When high-definition television comes, you'll have the added features of no flicker and better resolution. There'll be 1250 lines instead of the 30 lines that we had with the Baird Televisor. And where are things going? Well, we can look forward to 1 meter size flat panel television, maybe 3-dimensional television. We also have the possibility of optical tape recorders and digital video interactive. The rate of change is tremendous. They say that a week is a long time in politics. Well, I assure you, a day is a long time in this business. We've moved a long way since Nipper 90 years ago. There you see, I brought Nipper up to date. The reason for this rate of change increase is better and better communications. And that's the theme of my next lecture. Thank you for being such a good audience.